All right, you guys, we're talking about horizontal and oblique asymptotes of rationals. Now, let's just make sure we all understand that another word for the word oblique would be slant, a slant asymptote. So we're going to talk about how we know when a function has a horizontal asymptote, how we know when it has an oblique asymptote. The key things to know here is that asymptotes, the purpose of them is to guide the end behavior. So for example, if I had some kind of graph that had, let's say, a horizontal asymptote, no matter what's happening in the middle, I know that my graph either above or below is going to finish towards my asymptote, even if it was truly an oblique asymptote, so one that was at a slant. Let's just say it was like this. Again, my graph is just going to follow along that oblique asymptote as x goes to infinity and as x goes to negative infinity. So that's what this says here. It affects the end behavior. That's the purpose. There will be at most one for any rational function, at the most. So a rational function could either have none or it could have one, but it will never have more than one. And the function can touch and cross a horizontal or oblique asymptote. That's a really common misconception. A lot of people think that there's no possible way for a graph to cross through, but it actually can. Why can't it? Well, remember what the purpose was for the asymptotes. It's to guide the end behavior. So no matter what's happening in the middle, it's just going to affect the ends. Okay, so looking at these examples. Here in the right column, it tells us what the horizontal or oblique asymptote is. So we're trying to figure out some common trends. Now let's take a look here. Let's look at the cases where the asymptote is an equation using x's. So here and here. Both of these are going to have oblique asymptotes. Now, if I look at the degree, if I'm comparing the degree of the numerator and denominator, I notice that the degree in the numerator is actually higher than the degree of the denominator. Okay, something to observe. Let's also take a look at when the horizontal asymptote was 0. Okay, let's compare the degree of the numerator versus the denominator. Notice that in both of these examples, that the degree of the numerator was smaller than the degree of the denominator. Last but not least, when the horizontal asymptote was equal to some kind of number, let's compare the degrees now. Well, the degrees here are equal, equal, equal. So then where are these numbers coming from? Well, it has to do with the leading coefficients. 1 divided by 1, 3 divided by 5, 3 divided by 3. And last but not least, the one we haven't labeled yet actually falls under the same category as these oblique asymptotes, where the degree in the numerator is higher. So it's possible that it could be none, or it's possible that it could actually have an oblique asymptote. So how to find asymptotes? I would definitely recommend writing this down. Horizontal asymptotes have 3 cases. Case 1, it's bottom heavy. So that's when the degree in the denominator is greater than the degree in the numerator. If that's the case, then automatically the horizontal asymptote is y equals 0. Let's say we have equal degrees, such as here. Well, then it's going to be equal to the quotient of the leading coefficients. The leading coefficient here was 3 divided by 3. Let's say it was top heavy, such as this case here. The degree of the numerator was greater than the degree of the denominator. So it doesn't have a horizontal asymptote. That's important to note. It could potentially have an oblique asymptote then. Oblique asymptote. Okay. So this is in the top-heavy scenario, and we would use long division to find the equation. Okay. And we would drop the remainder as well. We'll have more examples of that coming up here, but really important for us to know the different cases.